Welcome to Scholars Edge tutorial. In this video, we'll be looking at indices. Recall in our last video, we talked about indices and the laws of indices. So in this video, we'll be looking at questions under indices. We'll be seeing how we can apply those laws in the last video in solving questions under indices. So our question 1 says 5 raised to the power of x times 25 raised to the power of x minus 1 divided by 125 raised to the power of x plus 1. For our question 2, we have cube root of 64r to the power of minus 6 all raised to the power of 1 over 2. And for our question 3, we have 225 to the power of 1 over 2 plus 85 to the power of 0 times 256 to the power of negative 1 over 4. So let's start with question 1. For question 1, 5 raised to the power of x times 25 to the power of x minus 1 divided by 125 to the power of x plus 1. What do we do? First of all, express 25 and 125 in terms of 5. You can see 25 can be divided by 5, 125 can be divided by 5. So express it in terms of 5. How do we mean? If I'm expressing 125 in terms of 5, that means we'll be having 5 to the power of 2, because 5 raised to the power of 2 will give us 25. And for 125, if we express it in terms of 5, we'll be having 5 to the power of 3, because 5 raised to the power of 3 will give us 125. So if we do that, we'll be having 5 to the power of x times 5 raised to the power of 2, which represents 25, then x minus 1, which was here. Then for 125, we have 5 raised to the power of 3 and the power, which is x plus 1. We bring down here. So next thing is, since we've expressed these numbers in terms of 5, what then do we do? You can see we have 2 brackets x minus 1 here and 3 brackets x plus 1 here. So we expand these brackets, meaning we open these brackets and we also open these brackets. Opening the brackets, we have 2 into x and 2 into negative 1, 3 into x and 3 into 1. So let's do the math together. 2 into x is what? 2x. So we're writing down our 2x. 2 into negative 1 is what? Negative 2. So write down negative 2 here. Coming down to the denominator, 3 into x is what? 3x. So write down our 3x here. And 3 into 1 is what? 3. So write down our plus 3 here. So this will give us 5 raised to the power of x times 5 raised to the power of 2x minus 2, all divided by 5 raised to the power of 3x plus 3. After we've gotten this, what's the next thing to do? The next thing to do is, remember when we were talking about the laws of indices, we talked about multiplication law. The multiplication law says that if the bases are the same, you pick one and you add the powers. So we would be applying that law here. We have 5 here, we have 5 here, meaning the bases are the same, and we'll pick one and add the powers. So we would be having 5 raised to the power of x, which is this x here, plus 2x minus 2, which is here, then divided by 5 raised to the power of 3x plus 3. We can rewrite this. Writing this, we have 5 raised to the power of x plus 2x minus 2 divided by 5 raised to the power of 3x plus 3. So it's all the same thing. The only difference is we just introduce the division sign. We remove this one and replace it with this one. Now recall the division law. The division law, when we talk about laws of indices, where we say if the bases are the same, you can see this base and this is 5, this is 5, so they are the same. If the bases are the same, you pick one and you subtract the powers. So we'll be picking one from this 5 and then we subtract these powers. So we would be having 5 to the power of x plus 2x minus 2, which is from this one, minus 3x plus 3, which is here. So now that we've gotten this, next thing is to collect like terms. We collect like terms from this one. You can see x is here, we have 2x here, we have -2, -3s, plus 3. So we collect like terms. Collecting like terms, we have 5 raised to the power of x plus 2s minus 3s. We brought all those ones that have s to the left hand side. Then we have plus 3, which is this, minus 2, which is this. So the whole numbers we brought it to the right hand side, and the ones with s we brought them to the left hand side. So if we express this, s plus 2s will give us what? 3s. 3s minus 3s will give us 0. So yeah, we already have 0. And then plus 3 minus 2 will give us what? 1. So 0 plus 1 is 1. So this will give us 5 to the power of 1. And anything raised to the power of 1 is always that number. So 5 to the power of 1 is what? 5. So the answer is, so our answer is 5. This is our final answer, because 5 raised to the power of 1 is 5. So this is how we can solve this question. Let's look at question 2. So for question 2, we have cube root of 64r to the power of -6 all raised to the power of 1/2. Now, what's the first thing to do here? What is the first thing to do here? This is cube root, because the 3 is inside this sign. So the first thing to do is to express this value. See this value, this is the 4r to the power of -6 all raised to the power of 1/2. Express this value inside this cube root. So expressing this, recall power law. Power law, we said whenever we have a number raised to the power of something, to the power of another number, enclosed in a bracket, all raised to the power of another number, we would express them in terms of the outside power. What do I mean? So we'll be doing 64 raised to the power of 1/2 into r raised to the power of -6 times 1/2. -6 times 1/2. These two powers we multiply, because r already has a power which is -6. So this power of r and this power outside we multiply, whereas 64 has a power which is 1. So 1 times this is 1/2. So 64 to the power of 1/2 into r to the power of -6 times 1/2. So this is what I mean. Cube root of 64 to the power of 1/2 into r to the power of -6 times 1/2, which is still, this is still times 1/2. Forget about being enclosed in the bracket. So what is the next thing to do now? Next thing is we multiply these two powers. 6 times 1/2, what will it give us? 6 times 1 is 6. So we're having -6/2. -6/2. So -6/2. We have cube root of 64 is to the power of 1/2 into r is to the power of -6/2. When we have -6/2, we can reduce this. 2 here, 1. 2 into 6 is 3. So we'll be having r to the power of -3, because we reduce this. 6 divided by 2 is 3. So r to the power of -3. Now that we've expressed r in terms of -3, we have cube root of 64 is to the power of 1/2 times r raised to the power of -3. Next thing is, let's work on 64 to the power of 1/2. How do I mean? Recall I said anything raised to the power of 1/2 is same thing as square root of that thing. Whenever I see a number raised to the power of 1/2, it means square root of that number. If you see a number raised to the power of 1/3, it means cube root of that number. If you see a number raised to the power of 1/4, it means fourth root of that number. So 64 to the power of 1/2 means square root of 64. Now we can rewrite this. Okay, let's just solve for this, and let's leave this cube root first. Let's leave this one first. When we've expressed this, then we can bring it back. So let's leave this cube root first. So we are having square root of 64 times r to the power of minus 3. Remember I said let's leave this cube root first. Let's solve this first. Then after we finish solving it, we can now record this cube root. So square root of 64 is what? 8. So we'll be having 8 times r to the power of minus 3. And if we have 8 times r to the power of minus 3, that will give us 8r to the power of minus 3. Now we've arrived at this point. Next thing is to recall our cube roots. Remember we have cube roots. So place this stuff we've gotten, this 8r to the power of minus 3, back into the cube root. So we'll be having cube root of 8r to the power of minus 3. Now what can we do to remove this cube root? Recall I said anything raised to the power of 1 over 2 means square root. So anything raised to the power of 1 over 3 means cube root. Now we are having cube root here. We can express 8r to the power of minus 3 in terms of power, meaning that we will be having 8r to the power of minus 3 or raised to the power of 1 over 3, since it is cube root. If it was maybe fourth root or square root, okay, if it was square root, it would have been 8r to the power of minus 3 or raised to the power of 1 over 2. If it was also fourth root, we'll be having 8r to the power of minus 3 or raised to the power of 1 over 4. But for the fact we are having cube root, so it will be 8r to the power of minus 3 or raised to the power of 1 over 3. And if we have this, recall power law of indices, where we have to express these terms, each term here in terms of this power. So 8 to the power of 1 over 3 and r is the power of minus 3 to the power of 1 over 3. So 8 here has the power of 1. So 1 times 1 over 3 was 1 over 3. So 8 to the power of 1 over 3. R to the power of minus 3. R here has the power of minus 3. Minus 3 times 1 over 3 is what? Minus 3 times 1 is minus 3. So minus 3 over 3. So r will be raised to minus 3 over 3. And minus 3 over 3. Okay, let's not go there. Let's solve this one first. 8 to the power of 1 over 3 into r raised to the power of minus 3 over 3. So recall anything raised to the power of 1 over 3. Anything raised to the power of 1 over 3 means cube root of that thing. So we'll be taking the cube root of 8. The cube root of 8. We'll write this 8 to the power of 1 over 3 as cube root. So cube root of 8. Then for minus 3 divided by 3. Minus 3 divided by 3 is what? Is minus 1. So r to the power of minus 1. Now since we have cube root of 8 times r to the power of minus 1, cube root of 8 is what? Is 2, because 2 raised to the power of 3. 2 times 2 times 2 will give you 8. So cube root of 8 is 2. R to the power of minus 1. So 2 times r raised to the power of minus 1. Now we are having r raised to the power of minus 1. Recall the negative index law, where I said anything raised to the power of a negative number, if it's a negative number like 1, like r raised to the power of minus 1, it means 1 over that thing. So r raised to the power of minus 1 means 1 all over r. If you are still wondering how possible is that, watch the previous video on indices, where we look at the laws of indices. You will understand this better. So negative index law says that anything raised to the power of a negative number is 1 all over that thing. So 2 times r raised to the power of minus 1. This r raised to the power of minus 1, we write it as 1 all over r. So we have 2 times 1 all over r. And if we are expressing this, 2 times 1 over r, 2 times 1 is what? 2. So we are having 2 all over r. And this is our final answer. 2 over r. So you can see that it is very easy to solve. This didn't take up to 10 lines, and we've solved this step by step. So let's look at number 3. So question 3 says 225 to the power of 1 over 2 plus 85 to the power of 0 times 256 to the power of minus 1 over 4. So how do we solve this? First of all, the step I'll be showing you, we'll solve these terms individually first. Solve them individually. When you get their values, you now replace them and we solve. So let's solve for the first one, 225 to the power of 1 over 2. So 225 to the power of 1 over 2. Recall I said anything raised to the power of 1 over 2 means square root of that thing. So square root of 225. Square root of 225 will give us 15. So we have 225 to the power of 1 over 2 equals 15. Now that we have this at 15, let's solve for the second term, 85 to the power of 0. Now recall the zero index law where we stated that anything raised to the power of 0 equals 1. So 85 to the power of 0 equals 1. So we have 1 here. So you can see how we are expressing these terms individually. Then for 256 to the power of negative 1 over 4, when we have something like this, you can see there is a negative sign. So since there is a negative sign, we apply the negative index law, meaning that we take 1 over 256 to the power of 1 all over 4. Recall it's raised to the power of 1 over 4. The reason we are taking 1 over is not because of the 1, but because of the negative sign. So this negative sign in the power represents 1 over. So we are taking 1 over 256. And what was raised to the power here? What was the power here? 1 over 4. So 256 to the power of 1 over 4. Now if you have this as 1 over 256 to the power of 1 over 4, what is the next thing to do? You recall I said anything to the power of 1 over 4 means 4th root of that thing. Anything to the power of 1 over 2 means square root. Anything to the power of 1 over 3 means cube root. Anything to the power of 1 over 4 means 4th root. Anything to the power of 1 over 5 means 5th root. So just like that, anything to the power of 1 over 4 means 4th root. So we'll be taking the 4th root of 256. So we'll be having 1 over 4th root of 256. And then what is the 4th root of 256? The 4th root of 256 is 4. So we'll be having this as 1 all over 4. So you can see we first of all express this term and we find out that 225 to the power of 1 over 2 is 15, 85 to the power of 0 is 1, and 256 to the power of 1 over 4 is 1 all over 4. So next thing is to substitute this into these positions. So we'll be having 15 plus 1 times 1 over 4. You can see this 15 here is for this, the 1 is for this, and 1 over 4 is for this. So 15 plus 1 is what? 16 times 1 over 4. And if we do this, 16 times 1 over 4, 4 here, 1, 4 into 16 is what? Is 4. Or you can just do 16 times 1 over 4, which is 16 times 1 is what? 16. So 16 divided by 4 is what? Is 4. Whichever way. So our answer is 4. So this is how we can solve questions under indices. Recall all the steps followed. You can see I followed it step by step so you can understand, both for this, for all of them. So recall the steps and solving questions under indices won't be a problem. So if you enjoy this video, or if you're enjoying this video, subscribe, like and comment. Now let's solve the next sort of questions. The question says solve for x and y in the following. 2 raised to the power of x equals 32, 2 raised to the power of y equals 0.25, and 3 raised to the power of 2x equals 27. So we are asked to solve for x, y and x in this. So let's start with question 1. So question 1 says 2 raised to the power of x equals 32. The first thing to do here is to express 32 in terms of 2. Express 32 in terms of 2. Why? So that they can have the same base. That's why we are expressing 32 in terms of 2. So if you are expressing 32 in terms of 2, we would have 2 raised to the power of 5, because 2 raised to the power of 5, 2 times 2 times 2 times 2 times 2 will give us 32. So we'll change this 32 here to 2 raised to the power of 5. So we'll be having 2 raised to the power of x equals 2 raised to the power of 5. Now that we have gotten this and they are in the same base, you can see 2 here, you can see 2 here. What do? We cancel out. Since they are the same base, we cancel out. So we'll cancel this 2, cancel this 2. Why are we cancelling? Because they are in the same base. So if we cancel out, we'll be left with just the power. So we are left with x here and we are left with 5 here. So we equate these powers. This is x here, which is the power for this, and this is 5, which is the power for this. And equating it, you have x equals 5. So this is our final answer. Yes, it's as simple as that. This is how we can solve this kind of question in few seconds. So you don't need to stress yourself. First of all, you express this in terms of 2 so that they can be in the same base. You cancel out and you equate the remaining thing. Since this is just x and this is 5, so x equals 5, and this is the value for x. So you can see that 2 raised to the power of 5 will give you this 2. Very simple. Now let's solve for question 2. Question 2 says 32 to the power of y equals 0.25. You can see this one now is quite different from this one. So how do we solve this? So first of all, we express this in terms of 2, and for 0.25, this is a decimal. This is a decimal. So since this is a decimal, we change it to fraction. 0.25 converting to fraction, we have 25 over 100, and we'll be having 32 raised to the power of y equals 25 over 100. If you express this further, 25 here 1, 25 here 4, so we'll be having 1 over 4. So we have 32y equals 1 over 4. Next thing is 1 over 4. How can we write this? Bringing this 4 up, we'll be having 4 to the power of negative 1. Remember the negative index law. Negative index law, assuming we had 4 to the power of negative 1, we're writing it to have 1 over 4. So we want to bring this back to negative index law, which is 4 to the power of negative 1. And for 32 to the power of y, we express this in terms of 2. Expressing this in terms of 2, we have 2 raised to the power of 5. So for here we have 2 raised to the power of 5 into y equals 4 to the power of negative 1. And expressing this, recall the power law, where if we have a power inside and a power outside, we multiply the two powers. So 5 times y is what? 5y. So we'll be having 2 raised to the power of 5y equals 4 raised to the power of negative 1. So now that we have 2 raised to the power of 5y equals 4 raised to the power of negative 1, we express this 4 raised to the power of negative 1 in terms of 2, so that they can be of the same base. In order for us to cancel out, so we have to express this in terms of 2. Now expressing this in terms of 2, we have 2 raised to the power of 2. So 2 raised to the power of 2, we replace this 4 by 2 raised to the power of 2 to negative 1, because we already had a power here. So we multiply the two powers. 2 times negative 1 is what? Negative 2. So we have 2 raised to the power of 5y equals 2 raised to the power of negative 2. And since the bases are now the same, we cancel out. And if we cancel out, we are left with the powers 5y and negative 2. So we equate it. So we have 5y equals negative 2. Now that we have this, we can now solve for y. For us to solve for y, we divide both sides by 5. And if we divide both sides by 5, can see we divided both sides by 5, we left with y equals negative 2 over 5. So our y equals negative 2 over 5. This is the value for y. Now let's solve the last one. Question 3. 3 says 3 raised to the power of 2x equals 27. Now what are we going to do first of all? First of all, we express this in terms of 3, so that they can be of the same base. And expressing this in terms of 3, we have 3 to the power of 3. 3 to the power of 3 will give us 27. So we replace 27 with 3 to the power of 3. And since we have 3 raised to the power of 2x equals 3 to the power of 3, we cancel out the bases because the bases are now the same, so we cancel it out and we will be left with the powers 2x and 3, so we equate it. So since we have 2x equals 3, we can now find x. For us to find x, we divide both sides by 2, which is the coefficient of x, and we see 2 here and 2 here, so we cancel out 3 and 2 here. 2 cannot divide 3, so we are left with x equals 3 over 2. Now the value for x is equals 3 over 2. So this is how we can solve simple and easy questions under indices. So far, if you enjoyed this video, ensure you subscribe, like and comment. In our next video, we'll be solving more questions under indices, so watch out for our next video under indices. Subscribe, like and comment.